hey. All right, let's see what tutorial we're gonna do today. Let's see here, walking down the list. Today, let's do, God, what I want to do today. Let's do something interesting here. Let's do, decouple front ends. Let's do password hashing. Password hashing. We've already done this, but let's do it again. All right, so today we're going to go over password hashing. Next slide. So why do you want a password hash, or what is password hashing? Basically, it is, we were talking about MySQL databases in the last tutorial, but when you have a web application, usually you have, or for a lot of web applications, you have login, which is username and password to log in to see your account. And in the backend database, obviously, or maybe not obviously, you don't want to store the password in clear text. And the reason for this is, next slide, is if a hacker gets into your database, then they can see your passwords. It's not your passwords, your passwords. They can see everyone's password in clear text format. Okay. You may be saying, well, if they hack the database, then they're in the database anyway, so the data is compromised. However, you should not be storing clear text passwords, because perhaps this user uses the same password across multiple websites, or they might have embarrassing passwords such as this or something else. So anyone, let's say a nosy admin as well. It might not be a hacker. It might be a nosy admin looking in the database, because admins usually have database access and they can see everyone's password in clear text format. Okay, so the reason for password hashing is so that we can, in a sense, encrypt the password. We're actually not really encrypting here, we're hashing it. But technically, you can think of it as encrypting the password so that anybody looking at the database or has eyes into the database cannot see the password in clear text format. Okay, so let's say a hacker or a nosy administrator, they have access to the database and they cannot see the clear text password, as I have repeated about 10 times already. Okay, so how do you hash a password, and how do you, let's say, unhash a password, if that concept even exists? We'll see. So actually, before we talk about that, let's look at this. Let's say we have this yellow box here, which is a hashing algorithm. Okay, so actually, I'm going to answer that question I just posed about a few seconds ago. Is, can you unhash a password? For example, let's say when you hash a password, can a hacker, let's say they have the hashing algorithm, can they unhash it, such as reversing it like this and then seeing, an embarrassing password such as this? And the answer to that is no. Okay, so the unique and very secure thing about hashing algorithms is it's a one-way algorithm, meaning you can start from clear text and go to hashed text, but there's no way you can go from hashed text back to clear text. So this is a very secure mechanism provided by hashing algorithms as such. But yeah, so you can't go backwards. So I had a few slides pretty much saying the same thing here. Repetition is my okay. But anyway, so how does login work for a user then? Let's say if they have a hashed password in the database, then how can they log in with their clear text password? So what usually happens is when the user enters their username and their clear text password in the browser, then in the backend server, it's going to go through a hashing algorithm, again, which is one way. and then it's going to convert it to, let's say, the hashed form of the password, and then you're going to look through your database which hashed form of the password matched that password that was just hashed. Okay, and then that will return the user, or let's say Ken123 here is going to compare the hashed password to the password stored in the database. Again, a hashed password stored in the database. And then it's going to compare the two. If it matches, then it means it's a successful login. Stuttering today. Okay, so let's see here. User visits the login page, enters the wrong password. So obviously, if they enter a wrong password, if it goes through the hashing algorithm, it's not going to produce that same hash that was stored in the database. So it's not going to match. So the user will be denied the login attempt. All right, so again, if the user enters the right password and it goes through the hashing algorithm, it will match the password that was hashed during, let's say, during registration when the user entered the password they want to use. At that time, we hash the password using that same hashing algorithm. We store it in the database, and then at any future time now, we use that same hashing algorithm to try to compare the password that was entered. Okay. So let's say there was a hacker that was able to access the database and see all the hashed passwords. Can they actually do anything with that hash password in terms of logging into the website? And the answer is pretty much no. Because let's say if the user, or let's say the hacker, enters that hashed password into the password field, what's going to happen is it's still going to go through that same hashing algorithm, and it's going to produce probably something totally different here, a hashed form of that hashed password, and that's definitely not going to match that hashed password, the correct hashed password in the database. Okay, so, oh, that was pretty quick. So in conclusion, avoid storing pure passwords in databases. The good practice is to store hashed passwords before storing them in the database. That sentence didn't make sense. But good practice is to hash the password before storing it in the database. Okay? So if you want to learn more, here is a good link about hashing security. I believe this is where I got information of this presentation. And thank you very much.